This is the FlashForge Creator 5. Like the SnapMaker U1, it has 4 independent toolheads capable of multicolor and multimaterial 3D printing. Like the Bambu Lab P2S combo, it has a 256mm cubed build volume. But unlike both of those options, the Creator 5 doesn't cost $999 or $799. No, this one somehow costs $699. So in this video, we're gonna try and figure out how, and more importantly, were the trade-offs actually worth it? Let's get after it. Now, real quick, before we get started, I do have to let you know this is a pre-production unit that I received at no charge. FlashForge did also sponsor this video, and they will see and approve it before you. I also will earn a commission should you choose to buy one. But as always, my opinions can't be bought, and I'm not afraid to burn bridges or ruffle feathers if it means saving you guys from wasting your money. Especially because, to be completely honest with you guys, this is actually a brand new relationship. In fact, it's actually the first time I've ever used any FlashForge 3D printer. So why start now? Well, because when FlashForge reached out and told me about their latest machine, I had a lot of questions, and I just could not resist the opportunity to answer them hands-on. So here it is, the FlashForge Creator 5. And of course, the biggest question, how? How is this machine so affordable? And what does that actually mean for us? See, to be able to sell a 4-tool head machine for just $699, and no, I still have not gotten over that price, the folks over at FlashForge must have made some pretty smart engineering trade-offs, right? So let me walk you through the ones that I've found. The first, and probably the most impactful one, is actually the toolhead design. Have a look at these lightweight little toolheads. Do you notice anything unique about them? There's no extruder motor. It actually stays on the carriage, and it uses an ingenious design to then couple the extruder gears to the motor on every single tool swap. I mean, after all, stepper motors are expensive, so why pay for a bunch of extra ones that are just gonna sit around while the toolhead is not in use? Then there's the coupling mechanisms. Instead of using heavy and expensive CNC machined mechanisms to actually lock the toolhead in place, FlashForge has chosen to just use very strong neodymium magnets. And instead of pogo pins and extra PCBs to communicate between the toolhead and the carriage, they're just running an additional USB cable to each one of these toolheads. And I'll admit it, I was impressed by the ingenuity. And the savings continue on the filament side. Instead of more complex spool holders that probably cost a few bucks each, we get a simple hook. Instead of convenient pre-feeders that grab the filament and push it all the way to the toolhead until it's detected, we just get an extruder lever that you can manually push to load the filament. Now, one benefit of making this a manual process is that FlashForge has actually integrated a filament cutter right into the toolhead, which theoretically should make it possible to add on a multi-material unit to each one of the toolheads down the line. Then there's this and this. That's right, no door up front and no viewing window in the back. There's also no HEPA filtration, no chamber heater, and no top hat. All of those things are included on the Creator 5 Pro, which somehow is only $150 more at $849. But there's one thing that you definitely won't find on either the Creator 5 or the Creator 5 Pro, and that's RFID readers. Unlike SnapMaker, who includes 4 of them, or Elegoo, that has just the one, FlashForge has decided to omit them completely to keep the price down, which honestly might be a smart move until the industry gets its stuff together and decides on one universal standard. I mean, I can't be the only one who has filament with 9 different types of RFID tags, none of which ever seem to be the right type for the printer I'm trying to print with. And then there are the little things. A rolled piece of sheet metal instead of carbon rods for the X gantry, extensive use of injection molding, purging down the side of the bed rather than into an injection molded bucket, no spare tools that you probably already have kicking around anyways. Small filament samples instead of 4 half-kilo spools that dramatically increase the shipping costs. I'm not an engineer, but even I could probably spot and list about 30 different deliberate optimizations that FlashForge has made to be able to hit this price point. But the real question is, do any of these sacrifices actually matter to the Creator 5's target customer? Do they affect print quality, user experience, or the long-term reliability of the printer? Or are they clever and in some cases just previously untapped means of driving costs down for the end customer? We're gonna answer all of those questions in a little bit once I've had the chance to really put some serious hours on this printer. But before we do, let's talk about where they didn't save money. First, the fit, finish, appearance, and most importantly, the build quality. I may be biased, but sponsored video or not, this seems like a very well-built machine. I noted earlier that this printer makes use of a lot of injection molding, but the frame itself is, of course, metal. And the entire top seems to be made out of one aluminum block. This is a stark contrast to the plastic outside, stamped sheet metal inside design of many modern 3D printers. And as a result, the Creator 5 feels a lot more premium than some of the other printers I've tested recently. I'm honestly pleasantly surprised. Additionally, you can tell that the very important coupling mechanism on the toolhead, and really just the entire toolhead itself, is very well made. It feels high quality even if they are using a lot of plastic on here. There are precision machined parts and assemblies that fit together beautifully. The XY motion system, while strapped onto a piece of sheet metal, seems to be another area where they really didn't skimp. You get a linear rail for X. I'm calling this X even though the printer is turned 90 degrees, so this seems like Y. And then you also get linear rods and bearings on Y. Another thing they didn't skimp on is assembly, or in other words, trying to save labor costs by passing the work on to the end customer. Actually, they pre-assemble all 4 tools into one big subassembly, which makes it significantly faster and easier to get this printer set up and running over the other tool changers that I have around the studio. Additionally, it does seem that at least my machine was fully assembled and tested thoroughly before shipping. And before you think to yourself or comment down below that this must mean that my machine was cherry-picked, I'll note that this has become a standard practice at many different companies, and when I toured SnapMaker's factory, I could actually see how they were extensively testing every single machine before then disassembling it and packing it up to ship it. So I'm very glad that QC, at least for my unit, was not somewhere that they cut costs. But this isn't a piece of art meant to just sit on a table. It's a 3D printer. And what really matters is how it prints. So now that I've got it all set up and calibrated, let's put some real print hours on it and see what it's capable of. And I'm back. Hope you guys like the new haircut. So as of right now, I've put about 60 hours on this machine in a variety of different materials, including PLA, PETG, TPU, PBA, and PCTG. So let me show you guys what I've made. Now, a side note, I'm generally pretty guilty of gushing over exciting new printers and explaining everything away as user error, and this is a sponsored video, so I am going to try and actually keep my own commentary to a minimum. I will explain the cause of any print defects, but you guys can let me know what you think of these print results down in the comments below. Also, I will note that on the current firmware, I actually don't have any way to see how long any of the prints actually took, and I don't want to give you guys inaccurate slicer estimations, so I apologize that there are no real print times here. So obviously, first I printed the obligatory Benchy in 4 colors out of various different shades of Polymaker's Pan Chroma Matte PLAs. Here's how it turned out. Benchy out of the way, let's go ahead and move on. For my next print, I went with something a little bit more challenging. This Teenage Mutant Ninja Turtle Sculpt Bust by Eastman, and it uses a combination of different Polymaker filaments. Now, as usual, I just couldn't afford the time of spending 2 hours perfectly painting every little detail on the model, but I figured that leaving some of these tiny little touches of green would actually be a good opportunity to see just how tiny you can go with the level of detail at the different intersections between different colors. And that actually turned out to be a very worthwhile experiment, because after seeing how tiny you can actually go, I changed some of the very tiny details on the subsequent model that I printed, which I'm going to show you guys in just a second. Anyways, I know that a lot of you guys have much higher print quality standards than I do, but to me, besides the painting blemishes, this is actually a super nice looking print. My only regret is that I chose to print this in a 0.2 millimeter layer height, since it would generally be considered stronger that way, and this is a bust for my 3-year-old. That choice worked out just fine for the majority of the model, but you can really see the stair-stepping on the top of the head and the rounded shoulders. Anyways, if I had to print this model again, I would definitely go for the 0.12 millimeter layer height. Moving on. So after that, I got curious as to how well the Creator 5 could handle materials besides PLA, particularly flexibles. After all, this is the first printer I've ever seen where the extruder motor and the filament gears are able to physically detach, and I was a little bit worried that this setup had forced them to make some sacrifices that would cause issues with flexible materials. So I went ahead and loaded up this awesome Trivenger model, which combines a Prusament PETG core with a flexible perimeter. But instead of TPU, I decided to try out some PIBA, because I honestly just think it's going to be really funny to watch this bounce off my kids' foreheads when they inevitably throw it at each other. Well, I am happy to report that the Creator 5 handled both of these filaments like an absolute champ, despite, as you can see, both of them not being properly dehydrated. From the looks of it, the automatic pressure advanced calibration does work very well, even though I printed the PIBA on a TPU setting, and loading and unloading reasonably high shore hardness flexibles of 85 and 90A was not an issue at all. Now, I am looking forward to doing some more testing with some softer TPUs as well, just to see how this setup performs, because there is a filament runout detection sensor here that makes the path a little bit more difficult to push wet noodles through, if you know what I mean. Up next, I went ahead and ran off a plate of these adorable little PJMasks Gekko statues for my 5-year-old. If you know, you know. These are made out of Prusament Galaxy Green PLA on the outside and Creality Hyper PLA for his little mouth. Now, I specifically did this because I wanted to see if the auto PA calibration would pick up on the fact that Prusament likes to flow very, very slowly, but the Hyper PLA likes to go a lot faster. And it definitely seems like it did. The only issue I had with these was that the prime tower got knocked over on both this print and the following one, but the fix for that was just a matter of switching to the rib prime tower design in all subsequent prints. And don't worry, because I have passed that on to FlashForge as feedback so that they can hopefully update that to be the default in their profiles. So at this point, the Creator 5 had definitely earned my trust, and I was ready to try out my most ambitious overnight print, this Miles Morales Spider-Man bust by Photosmith. What's special about it, and ambitious, is that it uses all 4 different colors of Prusament PLA on every single layer. Now, to add to that challenge, I chose to print it at a 0.12 millimeter layer height, which would end up being over 3,000 tool changes over the course of some 36 hours or so. I also took what I learned from the ugly paint job that I did on the Ninja Turtle, and I spent a good 45 minutes painting each one of these individual little zipper teeth and the various different cracks in the base. So if you appreciate me putting in the work, then please don't forget to give this video a like and subscribe to the channel if you haven't already. But for me, this was where the FlashForge flash swap coupling mechanism really proved itself. 3,358 tool changes and not one single failure, which is honestly very, very impressive considering that the prime tower fell over and left a huge spaghetti mess in its wake, which I would think would have gotten in the way of the mechanisms. By the way, that is why you see these little different colored blemishes and some of these issues up here. If I had to reprint this, I am pretty sure that the rib feature on the prime tower would completely prevent this issue. Now, as for the texturing on all of the different fabrics, that actually isn't VFAs or salmon skinning. That is actually the details in the model that the printer was able to successfully reproduce, which I'm honestly pretty happy with. But one thing that I really don't like about this print is how the bluish gray filament kind of transitions back and forth from matte to glossy at various different points in the print. Now, I know that I always claim user error, but this one genuinely isn't the printer's fault. And I do think it's a teachable moment to stop real quick and actually explain to all of you why it happened. So to save time on printing this model so I didn't have to run back to the studio, I decided to print both the bust and the base on the same build plate. And if you place them at exactly the same height here on my table and look at them next to one another, you can see that the different levels of shine actually correspond exactly to the changes in the geometry on the base. So basically what happened here is that as the base became thinner and thinner, eventually completing, the time between layers on the bust itself changed dramatically. This in turn caused the layers on the bust itself to cool at different rates, at different heights, creating this kind of effect. The easy fix would, of course, be to print each one of these parts separately, especially since it's not like we're purging all that much material every color change. But we might also be able to fix this through software. Prusa recently covered a similar issue on their blog when they announced a new feature in Prusa Slicer called Consistent Surface. And in Orca Slicer and all the forks of it, such as Flash Studio, we have a similar feature called Don't Slow Down for Outer Perimeters. Now, this honestly has more to do with slowing down the print speed to allow each layer to cool at a similar rate. But I'm very curious to test and see whether or not this could actually be used to compensate for the differences in layer times caused by one object finishing first. I know that's a run-on sentence, but drop a comment down below if you know the answer to that or would like to see me do some testing on it. And for my final print, I decided to go ahead and try this very cool multi-material pencil case by Protopasta. In it, I mixed Fiberlogy 40D TPU with 3D Fuel PCTG for impact resistance, and then I just used some silk PLA for supports. I also did enable support ironing to get that perfect finish on each one of these divots. Now, everything printed without a hitch, and I was once again very impressed with how well the automatic PA calibration actually worked. The FlashForge firmware currently doesn't allow you to select PCTG, so I actually put in PETG in the slicer and in the printer interface, and it was able to properly compensate for the different flow characteristics of those different materials. The print itself looks really, really good. The prime tower with the rib feature enabled did stay put this time, and the PLA supports detach really, really easily and very, very cleanly. So, what can I say without sounding like a shill? It does seem like the engineering trade-offs that FlashForge made to hit this price point have really paid off for them. And I'm going to be very curious to see if other manufacturers draw inspiration from things like the extruder motor coupling idea. I do have some feedback that I've passed along to FlashForge that I think will improve this printer, but it's almost all software and firmware related. But as we get closer to the production version of this printer and its software, I would be interested in revisiting this printer or its Pro big brother in a full, unsponsored and unbiased review, or even a comparison with the other tool changers I have in the studio. If you guys are interested in me doing a video like that, drop a comment below and let me know. Still, sponsored video or not, I don't feel like it would be fair to end this video without at least giving you some indication of what I actually think of the printer in exchange for you guys watching the video all the way to the end. Of course, take it with a grain of salt if you want, because FlashForge will review and approve everything I'm saying here, but know that I wouldn't say anything that I don't believe to be true. Overall, I think that this is a pretty solid printer, and it's well worth the price, especially if they fix the list of interface tweaks and slicer improvements that I and other testers have sent in. Sure, there are other printers on the market that have a more polished user experience or some more convenience features like pre-feeders, but even in its current state, I definitely wouldn't hesitate to recommend this printer to anyone who's looking to get a tool changer on a budget. And I'm really happy to see that the barrier to entry for true multi-material printing is about to come way down again. On that note, if you are interested in picking one of these up, I'm pleased to let you know that FlashForge has extended an additional $30 off the already low early bird pricing for TNL viewers, which brings the price of this exact machine down to just $669. At that price, I really don't think that you can go wrong just based on the hardware and the experience that I've had so far, so we'll leave a link in the description. And if you're still on the fence about whether or not to get a tool changer, you might want to check out this recent video I did on the channel. In it, I outlined 20 real-world and functional uses for multi-material 3D prints, from the practical and everyday stuff that you can already do now, to the theoretical and bleeding-edge use cases that still need more research and experimentation. I think it'll really open your eyes as to what's possible with this kind of multi-tool head printer. Anyways, that's all for this week, but I'll see all of you on the next layer.